morning. My name is Mohammed Zamira. My roll number is 219518041. Today, my subject is electronic device and circuits. My branch is electronics and communication engineering from B section. Today, my topic is early effect and its consequences. And its consequences. Early effect. At the early effect named after its discovery, James M. Early, in the variation in effective width of base in a bipolar junction transistor due to a variation in the applied base to collector voltage to the collector voltage. A great reverse bias across the collector base junction, for example, increase the collector base depletion width, thereby decreasing the width of the charge carrier portion of the base. Figure 1 top NPN base width for low collector base reverse bias, bottom narrower NPN base width for large collector base reverse bias, hashed area or depleted region. This is the circuit for NPN depletion region. VBE is NPN emitter collector base are connected to the NPN resistor. Second diagram is the early voltage. The early voltage VA as seen in the output characteristic plot of BJT. Active region, saturation region. Explanation in figure 1. The neutral, that is active base in green, and the depleted region base region are hashed light region. The neutral emitter and collector regions are dark blue, and the depleted regions hashed light blue. Under increased collector base reverse bias, the lower panel of figure 1 shows a widening of depletion region in the base and associated narrowing of neutral base region. The collector depletion region also increase under reverse bias more than does that of base, because the base is more heavily doped than the collector. The principle governing these two width in charge neutrality, the narrowing of the collector does not have a significant effect as the collector is much longer than the base. The emitter base junction is unchanged because the emitter base voltage is the same. Base narrowing has two consequences that affect the current. There is a lesser chance for recommendation within the smaller base region. The charge gradient is increased across the base, and consequently, the current of minority carriers injected across the collector base junction increases, which net current is called CB naught. Both their factors increase the collector or output current of the transistor within an increase in the collector voltage, but only the second is called early effect. This increased current is shown in figure 2. Tangents, the characteristics uh, at at the larger voltage explode backward to interrupt the voltage axis at a voltage called the early voltage, often denoted by the symbol VA. Large signal model in the forward region or in the forward active region, the early effect modifies the collector current IC and the forward common emitter current gain beta F as typically described by the following equations. IC is equals to IS e power VBE by VT of 1 plus VCE by VA. B, BF B, no, B beta F naught of 1 plus VCE by VA, where VCE is the collector emitter voltage, VBE is the base emitter voltage, VS is the reverse saturation current, VT is the thermal voltage, KT by Q. See the thermal voltage. Role is semiconductor physics. VA is the early voltage, typical 15 by 150 volts, smaller for smaller device. Beta F naught is forward common emitter current gain at zero bias. Some model base the collect base the collector current factor on the collector base voltage VCB, as described in the base width modulation instead of the collector emitter voltage VCE. Using VCE may be more physical plausible in agreement with the physical origin of the effect, which is widening of the collector base depletion layer that depends on VCB. Computer modules such as those used in SPICE use the collector base voltage VCB small signal model. The early effect can be accounted for in small signal circuit models such as hybrid PI model as a resistor defined as R naught is equals to VA plus VCE by EC is equals to VA by IC. In parallel with the collector emitter junction of transistor, the resistor can thus account for the finite output resistance of a small current mirror or an actively loaded common emitter amplifier. In keeping with the model used in SPICE as discussed above, using the resistance becomes R naught is equals to VA plus VCB by IC. Small signal model. The early effect can be accounted for in small signals circuits models such as hybrid PI model as a resistor defined as R naught is equals to VA plus VCE by IC is equals to VA by VC. Current voltage characteristics. The experience are derived for a PNP transistor. For a NPN transistor, N has to be replaced by P. P has to be replaced by N in all experience below. The following assumptions are allowed when derived derived ideal uh, when derived when deriving ideal current voltage characteristics of the BJT. Low level injections, uniform doping in each region with abrupt junction, one dimension current, negligible recommendations generation in space, charge region, negligible electric fields outside of space charge regions. It is important it is important to characterize the minority diffusion currents induced by injection of carriers. With regards of PNP diode, a key relation is the diffusion equation d square delta p b of x by dx square is equals to delta pb of x by lb whole square. A solution of this equation is below. Two boundaries conditions are used to solve and find C1 and C2. The following equations apply the emitter and the collector region respectively, and the origins. Delta NB x double dash is equals to a1 e power x double dash lb plus a2 e power minus x double dash lb. uh, Delta NC x dash is equals to b1 e power x dash lb plus b2 e power minus x dash lb. The early effect phenomena of BJT and its consequences. We have heard many times the early effect phenomena of BJT, but what is it? So here is this article. We will discuss about the early effect phenomena of a bipolar junction transistor in details. PNP transistor base collector base emitter base collector. The transition region at a junction is the region of uncovered charges on both sides of the junction at the positions occupied by the impurity atoms. As the voltage applied across the common base junction increases, the transmission region penetrates deeper into the collector and base. Since the doping is the base in the lower than the collector, therefore the penetrations the transition region in the base is much larger than into the collector. As a result, the electrical base width of the transistor is reduced in the comparison of metrological base width. The modulation of the effective base width of the collector voltage is known as the early effect, named after J.M. Early, who first interpreted the early effect phenomena. This decrease of the base with increased reverse collector voltage has some consequences, such as these there is less chance of recombination within the base region. The base the concentration gradients of minority charge carrier is increased within the base, since the whole current injected across the emitter is proportional to the gradient of the minority carriers at the emitter junction. The emitter current increases with increased reverse voltage current collector voltage. For the extremely large voltage, base width may be reduced to zero, causing the voltage to break down in the transistor. This phenomena is known as punch through or reach through effect. Thank you for giving this wonderful opportunity. Today, my topic has been ended here.